Hi guys, today we're going to take a look at situations where we don't get what we expect as far as lines crossing each other. So we're going to take a look at something called inconsistent systems and dependent systems. And we're going to use substitution to solve here. We also call this when answers get weird. So I'm going to try and solve these systems on the graphing calculator here, and you'll see what happens here. You can see we've got some fractions involved. So I'm going to go to y equals, and I'm going to input equation 1 and equation 2. So y equals, so it's going to be 2/3 x plus 3. And then I'll put in the other equation, which is 4/6 x minus 2. And when I hit graph, there's my first line, and there's my second line. And they don't cross each other. And that's what we're trying to find is, when we solve the system, is where they cross each other. And they don't seem to be crossing each other. So I'm going to take a look at the equations, and you realize when you look at the equations that 2/3 and 4/6 are equal to each other. Because if we write 4/6 in lowest terms, it's going to be equal to 2/3. So these two equations have the same slopes. They are parallel to each other. And if they're parallel to each other, that means that there are no solutions because there's no point of intersection. And when that situation occurs, we say that this system is inconsistent. So that system is called inconsistent when they're parallel and they don't cross each other at all. Now let's try the second system of equations here. So we've got equation 1 and equation 2 here. So the first equation is going to be 1 divided by 5 x plus 4 divided by 3. So some pretty messy equations here with these fractions. And the second equation, 2 divided by 10 x plus 8 divided by 6. And I'll hit graph on those. There's the first line. And there's no second line. So let's take a closer look at the equations here. These two equations, oh, they've got the same slope again. So 2/10, if we put it in the lowest terms, is going to be equal to 1/5. So these two equations have the same slope. And actually, if we compare the y-intercepts, 8/6 in lowest terms is going to be 4/3. So they have the same y-intercept as well. So if they've got the same slope and the same y-intercept, they are actually the same line. So when we look at our graph on our graphing calculator, that represents both lines because they are the same line. So when that situation occurs, when we've got two lines that are identical, they overlap each other, we say that they are a dependent system of equations. Okay? So that's a dependent system when we have that situation. Now, we could we may not see that all the time though. Like if I give you a bunch of equations and say solve these systems, you may not recognize whether it's inconsistent or dependent when you initially look at it. So let's see what it looks like when we try and solve a system that is one of these odd systems. So if we do that in the first one here, if I was going to solve this using substitution, I would say in equation 2, y equals 6 minus x. So I'm going to call that equation 3. And then I'll sub that equation 3 into the other equation, which is equation 1. So it's going to look like this. 2x plus 2, and 6 minus x goes in place of the y. That equals 7. So remember, we have to expand here. So 2x plus 12 minus 2x equals 7. And we've got 2x minus 2x, so they're going to cancel each other out. That's going to be 0. So I'm left with 12 equals 7. Well, 12 equals 7 is never true. So that means lines never cross. So that means that they must be parallel, so there's no solution. And remember, when they're parallel lines, we call it an inconsistent system. So that's what happens in the equation. We end up with something at the end that's never true. So that means the lines never cross. So that is an inconsistent system. So these questions are really weird compared to the ones we've done. I'm going to give you some example of some other weird things. There's a rare breed of sheep. Sorry, a rare breed of pig that looks like a sheep. That's pretty weird. I don't think I have to explain that. That's just weird. That is really weird. And one other weird thing. That's kind of funny, but it's kind of weird too. Okay. Sorry, I got sidetracked there. Let's take a look at another example here. We'll solve it by substitution and see what happens. So in equation 1, if I move the minus y to the other side of the equation is now going to look like y is equal to 2x minus 3. I'll call that equation 3. And now I'm going to sub that equation into the other equation that I haven't worked with yet. So that's going to be 3 times 2x minus 3 plus 9 equals 6x. And remember, I have to distribute here. So it's going to be 6x minus 9 plus 9 equals 6x. And minus 9 plus 9 is 0. So I'm left with 6x equals 6x. And if I move the 6x over to be with the other 6x, it's going to be 6x minus 6x. I'm going to end up with 0 equals 0. Well, if we compare that to what happened before, 0 is equal to 0. That's something that is always true. So if it's always true, that means the lines always cross. And if those two lines overlap each other, that means we have infinite solutions because they're right on top of one another, and that means that we're looking at a dependent system. So up here, this is an example of a dependent system. All right, one more example here. Sometimes we're going to run into situations, and I've given you a couple of these, I think, in yesterday's homework that we did on substitution. Sometimes we're going to get fractional answers. So it's important that we can handle that, okay, because we'll run into that. So for this one, in equation 2, y is going to equal 11 minus 4x. Call that 3. Now I'm going to sub 3 in 1. So in equation 1, I'll plug in 11 minus 4x where the y is. I expand the bracket. 5x minus 33 plus 12x equals 2. So I end up with 17x equals 35 when I collect the like terms together. So now I divide 17 on the other side. So x is equal to 35 over 17. So we've got the x part. Now we need to figure out the y part. So I'm going to sub x equals 35 over 17. And I can sub it into equation 1, 2, or 3. Probably equation 3 is going to be the easiest one to sub in. Because it's going to look like y equals 11 minus 4, and then times 35 over 17. So if I'm going to combine the 11 with what comes after it, I'm going to need to get a common denominator, which is 17. So 11 times 17 is going to give me 187 minus, I have 17 on the bottom here, and 4 times 35 is going to give me 140. Okay, so if I do 187 minus 140, I get 47 over 17. So there's the y. So therefore, point of intersection is 35 over 17, 47 over 17. Okay, great. So we're going to practice some of that in class tomorrow. Thanks.